Okay, so I'm going to go through, I think I got like 6 items, some have some sub-items here, but so first thing, what is a system of equations? Okay, or what are you going to say? Well, one would not make it a system. Yeah, but you said one or more, you can't include one. I mean, you just say more than one equation, more than one variable. In this class, all we really do is 2 equations and 2 variables. You could just say that, right? 2 equations, 2 variables. Yeah. Okay. So what do you think is the next question? Right? That is the, so there's the first one. I mean, you gave me the answer, so why do you need to write it down? Okay. 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 What is the solution to the system of equations? 100. That's not good enough. You can't just say an x and a y. Where they intersect, right? If it's 2 equations, it's a variable. If it's an equation and 2 variables, then it's got a graph, which is a straight line, right? And so where do the 2 lines intersect? That's the solution. Because why? Because that point solves both equations. You could plug it in and both of them will work. So that's the answer right there. The point that solves all the equations. In our case, both. Like for 2 equations and 2 variables, it's an intersection point on a graph, the kind of graph we're used to looking at. Like say, you could do it in 3 dimensions and look at it on a flat surface. It'd be kind of hard to see, but we do that in math and algebra. Okay, now, how do we solve a system by substitution? What's the first step, Connor? Right? So you solve one equation for one variable, right? That's the first step. Then what do you do with that? Okay. So then you plug in for that variable and the other equation, and you solve. And that'll give you the answer for one variable. Then how do you find the second variable? You go back to the, whatever you got at the end of the step 1, you had an equation, solve for one variable. That's the one variable you don't know yet. So you go back there. So we could do one if you want to see it. I guess, what you really need to do is when we put up the study guide, actually try it. Try it. Okay? So the answer should be the XY point. Now, the way the test is written, quiet please, the way the test is written, it says solve by any method. But the truth is that there's some of them, there's some of them, honestly, they're really kind of designed for one method or the other. Like the substitution ones are first and the elimination ones are next. I just took off the directions that said solve by substitution, solve by elimination. I just do whatever you want. But they really are set up sometimes like elimination if the variables are just opposite. I think it's actually easier just to add them up and cancel one. Yeah. For what? Of course. Okay. Yeah, that's the thing. If you're good with the calculator, first you got to be good at solving for y, right? Because they're not all ready to go in the calculator. Okay. How to solve by elimination? What's the ultimate goal in elimination? To get rid of one of the variables by either adding or subtracting, right? So how do you make that happen? So the first, I call it step 0. Step 0 is they need to be in standard form with the variable terms lined up. Okay. Step 1, not always necessary. Sometimes they're actually all ready to add or subtract the equations and you'll eliminate a variable. But if it's not, then you need to multiply one or both equations so that you got equal or opposite coefficients. That way when you add them or subtract them, you cancel. You eliminate. So you never move on to this step here to add or subtract unless you've created that situation to eliminate a variable. after you solve for that one variable, the first one, then where are you going to find the second one? You're going to have to go up to the original equation. It's not so clear with elimination where to find the second variable as it is with substitution. Substitution, you've got an obvious place to go. Here it doesn't matter. Take one of the equations. Probably before you multiplied it by a number, but you could take any one. It wouldn't matter. When we multiply one or both of the equations, right, and then we rewrite the system, what do you call that? It's an equivalent system. Why is it called equivalent? Because the lines are still in the same place, the solution is still in the same place. It doesn't change any of that by multiplying both sides by the same thing. If you want, I made one extra today, if you want. Okay. All right, how do you solve with the calculator? Graphing with the calculator. I mean, you could try to solve it just by the regular graphing, but then, your solution is only as good as your graphing. And unless you're really precise, then you got to check your answer. I mean, much better to know how to do it with the graphing calculator. It's kind of why we use them. So again, these are the steps for solving with the graphing in the graphing calculator. First, you got to enter the equations at y equals, right? Then you graph it. If the intersection point is on the screen, second, trace 5, enter, enter, enter. If the intersection point is not on the screen, zoom out, zoom 3, enter, and then do the same thing. But again, probably should have put another step on here. If they're not solved for y, solve for y first. I mean, that's a skill that we've been doing since first semester, way back into the first semester. And that's the reason why, it comes up a lot. Okay, describe a system of equations, the graph of a system of equations that doesn't have any solutions. Parallel lines, right? Right? Because if they're parallel, they never intersect, so there's no point in common on the both. So the answer is parallel lines. Describe the system that has infinitely many solutions. Right? If it has, if they don't have the same slope, then they're going to intersect at one point. If they're parallel, then they have the same slope but different y-intercepts. If they're the same slope and the same y-intercept, it's the same line, right? It may look different because it's not, both solved for y, but actually it's two equations that describe the same line, right? So one's on top of the other, they share every point, which is infinite. Okay, what is a system of inequalities? Right? More than one inequality with more than one variable, right? In this class, it was 2 inequalities with 2 variables. Actually, sometimes it was 3. And what is the solution to a system of inequalities? Right? Well, each inequality's graph is a line, solid or dashed, with shading. The solution to the system is where the lines and shading overlap. Okay. And that's it. I mean, that's what, I mean, now you need to practice that stuff with a study guide. There's about 20 questions. They got answers in the back.